Crib's mom.
Person into a base.
Greg Crib's mom.
Person into a base.
Yeah, it is Greg Crib's mom, isn't it?
Sliding into a
Greg
base.
Crib's mom, who wears things on her hair and doesn't have arms this time. She's going to slide to a stop, so maybe I don't really care where she is if she's on
Second base.
she's playing softball and sliding into a base, she's in an ice rink and took a spill, whatever, she's going to slide to a stop. So I want to talk about the force diagram here because people always get it wrong. Except you don't always get it wrong.
Never get it wrong.
So let's draw the force diagram on her. She's sliding this way. So what are the forces? Gravitas, yay, gravitas. And?
The normal.
The normal, yes.
And
Thrust and
What's the
friction.
formula for normal to find it?
What?
The formula to find normal.
What about it?
What is it?
There's not a formula for normal.
So you find that for G and F in the head. I don't know.
You guys skipping ahead. I'm just labeling forces. I'm not finding their values yet, I'm just labeling.
Friction.
Friction, which way is friction?
Opposite of the way she's sliding, which you don't know really because she could be going.
She's sliding to our right.
Okay, so it's going to the left.
The friction is to the left. What else?
Would it be called thrust? We go in the other way.
The thrust.
Greg Crib's mom is a lot of thrust. If you know what I mean.
I don't know what you mean, Max. And I'd prefer that you didn't tell me. Not while we're recording anything. Sick person.
I did get 0.69.
All right, guys. You can't solve the problem this way until you tell me something. What is pushing her forward? You said, oh, let's just call it the thrust. Okay, we can just call it the thrust, but what is it? What is doing it? What is pushing her forward right now? What? What is it?
Momentum.
I'm not talking to you, I'm talking to Caitlyn. What is it, Caitlyn? No, that is not correct. Try it again. Oh, come on, you think of something. What is it, everyone? If Caitlyn doesn't know, tell her.
I know. It's you.
What's pushing her forward right now?
You're pushing.
Opposite of friction.
I'm not.
She's pushing herself.
She's pushing herself.
Justice.
That usually doesn't work out very well. You push yourself and you just push yourself back. Wait.
Friction is pushing her.
Right, but friction is pushing her that way.
The opposite.
What's pushing her that way?
Force.
What?
Friction.
What is it?
Something that pushed her.
So you call it thrust, but what is it? What physical force is pushing her in this direction right now?
Acceleration.
Acceleration isn't a force.
Strong.
Electromagnetivity.
There's a reason you're having so much trouble identifying this force.
That's because you didn't say what's pushing her, right?
But initially,
You have
Why didn't I say what was pushing her?
Because you want to confuse us all.
Nope.
Nothing.
What?
Nothing was pushed.
Because nothing is pushing her forward. I never said anything was pushing her forward. Did I?
No.
The reason you're having trouble identifying this force is it doesn't exist. There's nothing pushing her forward. Why do you want there to be something pushing her forward?
Get she's going.
And the answer to that is she's moving forward, right? So you say, well, she must have a force forward if she's moving forward. Is that true? Is it true that to move forward, something has to be pushing me right now in that direction? Not true. All we know, if she's moving this direction, all that means is that a minute ago she was moving this direction, and because of the first law, she is continuing to do that. Right?
Yes.
In fact, you'll agree with me that she's going to move forward not for terribly long, right?
Mm-hmm.
She's moving this forward and she's going to stop. Therefore, which direction is the net force? If she's moving this way, but she's going to stop. She's being pushed this way, isn't she?
Yeah.
By?
Friction.
So friction is pushing her this way. Nothing is pushing her that way. In the past, when she began her slide, something had to push her forward. The ground pushed her forward as she, lunged off of it or whatever. Pushed herself with her feet onto the ground in that direction. Then she had a thrust force. But now she's just sliding to a stop. Nothing's pushing her forward. In fact, this is the entire diagram. Is there a net force here?
Friction.
There is a net force. These cancel, so the only force, which is unmitigated by anything else, is the friction force. Is this true? In this case, is this true?
Yes.
In every case, is this true?
No.
So this is what happens. People always ask me for formulas. There aren't a lot of times. When you get to this point of the problem in physics, you don't have a formula. You don't memorize the formula. You analyze the forces and you say, well, what's going on? And in this case, the net force is the friction force. And furthermore, we can, if we had more information, we could, answer whatever question they ask. But if you get to this point, how do we get to this point? Because something was moving forward, had a momentum, but was going to come to a stop. It's not at constant velocity, like a lot of our problems are, because there's nothing pushing it forward, so it's slowing down. So it's not at constant velocity. There's a net force this way. People have a lot of trouble with this at first. The idea that something can have a velocity in this direction, but a net force in that direction. Is that okay with you? Can you have a velocity in this direction, but a net force in this direction? All that means is the acceleration's in this direction, and all that means is that your velocity is getting smaller. You're slowing down. Anytime something's sliding, slowing down, rolling to a stop, that's going to be true. The net force and the velocity are not always in the same direction. On the elevator, we had problems like this, right? Where you would be going up, but you'd be slowing down, so your net force was down. Same thing. So, if this is true, what's the formula for net force? MA. What's the formula for friction? Mu Fn. All right, but the Fn in this problem, Fn is equal to Fg. And if Fn is equal to mg, then we can just write mg there, can't we? Because it's equal to the weight in this problem. Now, when you're asked this problem and it doesn't give you a mass, can you still do it?
The masses cancel out.
The masses cancel out, don't they? Whatever her mass is doesn't matter because it's on each side of the equation. They fall out. So it all reduces to that. That's pretty simple. So this, we've kind of gone through a lot of steps here to see that in a problem like this, where the net force is the friction, where the only really force that's not being canceled is the friction force, it falls out into this expression. Acceleration is mu g. And so there's a problem on the handwritten one where that will help you. So sometimes it'll give you the acceleration, you'll have to find mu. Other times it'll give you mu, you have to find the acceleration, whatever. It may not give you the acceleration, it may give you VI, VF, and T or whatever, and you have to figure out the acceleration. So that's how those work. Bye-bye.